Hi there, my name's Zohaib, and along with Dylan, Thomas, Alec, and David, we make up Team 57B. This is our submission for the Formula AI Hack of 2022, focusing on data analytics. In the objective for this hackathon, it was made clear how important weather data is in driving decisions made during a race. And while you may think weather forecasts already exist, why do we need to build a new model? Bespoke built short-term weather models are able to provide teams a critical competitive advantage. This is crucial with a series like F1 esports, with championship titles, hundreds of thousands in prize money, and the immeasurable benefit provided through increased publicity, all on the line. Mark Temple, Fernando Alonso's race engineer at McLaren, once said, "You can be staring at a radar image on the screen and not notice that rain is falling in the pit lane." What this really tells us is that general weather forecasts don't give the level of granularity needed for race teams to make strategic decisions with confidence. What there is a need for is bespoke models that can predict localized conditions specific to each track and give instant predictions in a short time frame. In scope with this hackathon brief and this context, what we've built is a model built on data from Oracle Red Bull Racing esports team that outputs what you can see on the table on the right. For specific time intervals, we can tell you exactly what type of weather to expect and a quantification of the likelihood you'll see rain. Through use of H2O AutoML as a means of model experimentation, our ensemble of XGBoost models predict for intervals of 5, 10, 15, 30, and 60 minutes into the future with pinpoint accuracy. We utilize Oracle's cloud infrastructure to deploy models which can conduct pre-processing and output forecasts in near real time, enabling teams to rely on predictions when it comes to making pit stop strategy decisions in race conditions or optimal timing for flying laps in qualifying. Our approach focused on ensuring that we frugally understood the data set and problem, removing and filtering rows through domain knowledge and exploratory data analysis. This allowed us to arrive at a data set with unique per second observations whilst maintaining relevant dimensionality and matched to true labels extracted from an advanced point in time, provided it existed within the same session. This data was then fed into multiple models which forecasted future time horizons to predict both weather and the probability of rainfall as a percentage. Additionally, we leveraged future forecasts as a proxy for true labels, in addition to SMOTE, to address class imbalances for longer time horizons. We leveraged the capability of Oracle Cloud infrastructure to quickly distill and iterate, given the big data nature of the problem, and this allowed us to quickly and effectively measure our engineering decisions. Our methodology centered on some key decisions we have made given the challenging nature of the dataset, while still appreciating the rationality of how a solution for this problem should be designed. We leveraged synthetic minority oversampling, or SMOTE, to address class imbalances, utilized the game's own forecasts with dynamic weather turned off, and made a conscious effort to build generalized models which are suited to a wider variety of uncertain scenarios. Our Python script and modeling pipeline can be deployed for real-time usage in F1 2021, enabling teams to develop race-winning strategies on the fly. Although this can mean winning championships and prize money, which doesn't sound too bad, the impact from this can be felt off the track and out of the game, as Red Bull Racing and title sponsor Oracle can enjoy better business outcomes through intangible and frankly, priceless benefits. We've seen this with Max Verstappen winning the 2021 World Drivers' Championship and look forward to seeing how the year of 2022 pans out. A big thank you from us at 57B to both Hackmakers and Oracle for making this happen.